So 0.6820, negative 0.9848, 0.9848, 0.1763, negative 0.6820, negative 0.6820, undefined, and 0.1763. All that was calculator work, yes? No problem. You all got them. Easy peasy, lemon squeezy. If you screwed up, you don't have this. What you probably did was you rounded this number wrong. You read the first 4 decimals, didn't check the 5th. That's the only thing you might have done wrong here. Everybody's cool, yes? Now, all of you should have noticed, as I said, some numbers gave you the same decimals. Those will be the ones I highlight in blue. Sine 43. Actually, it didn't give you the same decimal. Where did I get the same? Those two and those two gave you the same, right? And then different decimals will be green. That was those two and these two, right? You got different decimals, same numbers, one was positive, one was negative. And the question became, why? So to answer that question, it required you to show me, to answer that question well, you needed to do something like this. Why do you laugh at me so much? It hurts my feelings. Tap, draw. Screw it. There. You needed something like this, yes? And the ones that were the same, tan 10, tan 190. So where is 10? Right there, yes? Where is 190? Right there, yes? Right? What is the same there? Max?
They're 10 after the...
Their reference angles are the same, yes? Both reference angles are the same. And we remember C-A-S-T. So everything is positive here. The only other place that can have the same positive tan with a reference angle of 10 is this quadrant. Everybody understand? What if I told you it was 170? What would the reference angle be? You needn't feel bad. Disappointment and I are very good friends. All right. What if I told you that this theta, which is 170, so what does that make that R? 10. So what would its tan be compared to these two black R's? It would be the same tangent, except what? Negative. Because C-A-S-T. Understand? That's the whole point of this drawing. That's why I gave you this exercise. So the opposite ones, the same decimal, and then this one was sine 223 and sine 317, yes? So sine 317 has to be out here, right? And sine 223 has to be in here, right? No, I lie. Sorry, 223 has to be in here. This R and this R are the same. And since cos and tan are the positive ones there, that gave us negatives. Is everybody cool? It's the reference angle that we are actually using when we find the sines and tans. And reference angles change. The angle value doesn't change, but the opposites and adjacents change because of the coordinate plane. Is everybody good? Okay. So I asked you to do number 6. Given that theta is in the standard position angle. So what does that mean? That means we are starting with this, and theta begins on which line? If it's in standard position, theta begins on which line? Right there, yes? Now, what do I know about it? I know that its sine is 2 over 5, yes? What do I know about sine? O over h, or we have recently learned that it is also y over r, yes? Now, since sine is negative, where must this angle live? I shouldn't say that. Where can't this angle live? Can it be here? No. Can it be here? C-A-S-T. Can it be here? No. Signs are positive up there. So it has to be down here, doesn't it? Okay. Everybody understands? Now, since it's y over r, which one of those has to be the negative? The numerator or the denominator? The numerator. Why? Why does, what?
Because it's on the y-axis.
Because it's on the y-axis. This has to be the radius of our circle, which is always positive, isn't it? So I have to drop down 2 on the y-axis, right? Does it matter where I go on the x-axis? Not at all. All that matters is I drop down 2, or I drop down 2, and I draw this line. I'm going to use 2 different colors. There's that one, which gets me this, and there's that one, which gets me this. Everybody cool? Everybody understands? All right. Now, the question is asking me for the value of theta, yes? What finds me values of angles? Shift, and in this case, sine. So I need to go shift sine of what value? Negative 2/5. And that's going to get me a number. What number does it get me? Negative 24 degrees, yes? Now you guys are smart kids. Where is that 24? It's the reference angle, yes? So there is a 24. Since it's negative, I went that way, huh? So if that is a 24, what is the red theta? Red theta is what? All the way around is 360, but I removed how much of it?
23.
Minus 24 to get what? 336, right? What then is blue theta? Where does the 24 have to live over here? Where does the 24 have to live? In the reference angle, which is where? Where I have this big arrow here, yes? So this is 24, correct? How much is it to here? $180. And then what? Plus 24 to get 204. Can everybody work their way around a circle and the coordinate plane? Everyone is comfy cozy? Okay, now listen for a moment. If you're writing your quiz, continue to write your quiz because this is going to be on the video. Tomorrow, when I am not here, you are going to do an assignment on this stuff. In your books, it is page 77 and 78. Okay? You're going to do that tomorrow in class, I believe. I can't remember what I actually said yesterday because I wasn't really psychologically here yesterday. I was thinking about other things. Correct me if I'm wrong, but I believe that we decided tomorrow you would do this assignment and Friday you would do your cumulative, so you would have the whole 80 minutes. Did we? I don't remember, guys. That's what we are doing, yes? So you have the whole 80 minutes for your cumulative. And if you weren't going to be here, we were going to sort that out later on your time. Okay, see, okay. Quiz on Friday on just the circle trig. Okay, that's what I said. All right, that's what we're doing Friday. And then what I'm going to teach you today will be the rest of Friday because it's the last little tail end of circle trig. Okay? Everybody cool? All right, so tonight, I'm not giving you any work. I want you to leave page 77 and 78. I want you to leave that for tomorrow in class because I'm not going to be here. Okay? I'm also going to make an extra little sheet. I'll leave it with the TOC. If you get this and you need to fill up your time and you want some extra preparation for your quiz on Friday, it will be available for you tomorrow, okay? And I will post this assignment, page 77, 78, on YouTube tomorrow night so you can mark it before your quiz. Now, if you luck into getting a math teacher tomorrow, it's entirely possible you could mark this in class, but it will still be on YouTube for you, okay? I requested a math teacher. That math teacher got hired. She's in the school now doing other stuff. So I don't know who you're going to get. You might end up with an elementary school music teacher, which is fine, but chances of her being able to do unit circle trig or him being able to do unit circle trig are pretty slim. Okay? So you may have somebody tomorrow who says, I wish I could find the idiot who put the alphabet in math. You may get someone with that level of math ability. That's okay because you know what you're doing anyway. They just won't be able to help you, in which case you guys will have to help each other. All right? All right. Dylan, Josh, and Carmen, how are we doing? Two more? Josh? Just the back? You have one more? Okay. Everyone is good? Everyone can handle the CAST? Everybody understands why things are positive, where they're positive. Everybody understands X, Y, R is the same as O, H, A. Everybody's cool with that? Okay. So you are going to skip now the next 2 pages of your book and get to the page that is entitled Special Triangles. And then we are going to stop and take a moment while Carmen, Dylan, and Josh. We are back to recording. I'm going to introduce this while Max gets his drink of water. What is the general principle behind trigonometry? By that I mean, why does it work? Why does trig work? Why is the sine of 82 what it is? I call your attention back to the very first day of notes. Why, I lie, the second day of notes. Why does trig work? Why does SOHCAHTOA work? Wow, you should watch the video. Does this angle change? No. No matter how big the triangle gets, nothing changes, yes? Okay. That's why trig works. So now we come to this case. Here I have two what I call special triangles because they follow some rules that are really, really helpful. What do you know about a triangle that is 45, 45, and 90? Sam, it is an isosceles triangle. And what do you know about isosceles triangles? The two legs are equal, yes? So you know that this side is some length because you have eyes, right? What do we give it in math when we don't know what it is? A variable, x. Since this is an isosceles triangle, what is this side? X. Excellent. Since this is 90, what is this side? It's a hypotenuse. How do we find the hypotenuse? It's the square root of x squared plus x squared, yes? How many x squareds are that? 2. So it's a square root. Go for Myers. Hello. Sweet. Okay. No problem. Watch the rest. Okay. Everybody cool here? Everybody understands what I've done, yes? Now, you guys are smart kids. What is the easiest number that we could put in for x? Say it loud and proud, Nicole. 1. If x is 1, then how long is this? 1. And how long is this? Root 2. Everybody cool? And what do we know about trig now? That will this ratio ever change? No matter how big the triangle gets, it will never change, will it? Right? So look at what we have here and tell me 45. Which of these angles are 45? This guy and this guy, yes? Okay. What is the sine, cos, and tan of 45 according to the blue numbers here? What is the sine of 45? X over h? O over h? Or according to these blue numbers, what is it? 1 over root 2. What's the cos? 1 over root 2. And what's the tan? 1 over 1, which is 1. Everybody cool? Does it matter how big the triangle is? No. If I do 1 divided by root 2, I get the sine and the cos and the tan for all 45-degree triangles. Got it? Now, while we're at it, let's look at 90 for a sec, because 90 is weird, isn't it? And the reason I'm looking at 90 now is because up until now, we've only looked at up to 90, haven't we? We're aware that 90 is a degree, yes? we're aware that we can find sine, coses, and tans of angles bigger than 90, yes? Because we've done it. We're just finding the sine of 223. So I must be able to find the sine of 90, yeah? Look at that question. Tell me what the sine of 90 must be. It is weird. What is sine? Opposite over hypotenuse. Well, what's opposite to 90? The hypotenuse. So isn't the sine of 90 the hypotenuse over the hypotenuse? So what is that? 1. Sine of 90 is 1 because it's h over h. Got it? What is the cos of 90? What is cos? Adjacent over hypotenuse, isn't it? So what's adjacent? 1 and root 2, yes? But that would mean that the cos of 90 was the same as cos of 45. Does that make any sense? Are they the same angle? Are they references of each other? Maybe. What's cos on your calculator? What's cos of 90? 0. Why? Can you figure out cos of 90 from this? You can't, can you? Because there's two adjacents, yes? Because how do we define the adjacent side? It's the side that isn't the hypotenuse, yes? So which side do I use? Doesn't work, does it? So the cos is 0. Now we're going to do another one. How do I do tan? Opposite over adjacent. What's opposite of 90? The hypotenuse, right? What's adjacent to 90? There's two adjacents. Which one do you use? You can't. There isn't one. Right? So what number isn't? What number do we use to show isn't? Do I have any pizza in front of me? So there isn't any pizza in front of me, yes? So how much pizza is in front of me? 0. Right? So tan is opposite over adjacent, yes? What is opposite to 90? The hypotenuse. And what is adjacent? You don't know, because it doesn't have an adjacent, does it? So what would go down here? What number is nothing? 0. Can I divide by 0? No. So the tan of 90 is undefined. Now, please understand, in your previous math classes, your teacher would have told you 1, 0, and undefined. Right? That's not what grade 10 and higher is about. Here you got to know why. Is everybody cool with why? All right. So down here, just remind yourself that it's 1 over root 2 and sine is 1. Cos is 1 over root 2. Cos is 0. And tan is 1 and then undefined. That's the easy one. Can everybody follow it? Everyone's cool? Okay, that's the easy one. Let's look at this next one, the other special triangle that follows certain rules. 30, 60, 90. You guys are smart kids, yes? Which one of those sides is obviously the shortest? The vertical one or the horizontal one? Vertical one. Obviously the shortest, yes? So let's make it, what would be the easiest number to give that? 1. Everybody cool? Okay. Now, I'm going to do something a little weird here. Okay? which of those angles is obviously 30 degrees? The top one or the one on the right? Why do you know it's the one on the right? Because it's smaller. You all know this is 30, correct? Okay. Now, using what you know, let's fill in the rest of this. Okay? So I need an hypotenuse. What is it? How am I going to find that hypotenuse? I'm just doing regular trig. Sine 30 equals 1 over h, yes? Agreed? So h must equal 1 over sine 30, correct? What is it? 2. Once you know 2, can you find this one? What's this side? The square root of what? 2 squared minus 1 squared, which is the square root of 3. Cool? Everybody with me? Now, you guys just remembered that no matter what I do over here, it's 1 root 2, yes? If it was 18, it would be 18, 18, and 18 root 2, wouldn't it? So what is this over here? That gives me the guaranteed numbers. 1, 2, root 3, always. Everybody cool? So what then is the sine, cos, tan of 30? You've got the 3 numbers there. What are they? Sine of 30 is what? 1 over 2. Cos of 30 is what? Root 3 over 2. Tan of 30 is what? 1 over root 3. What is it for 60? You guys already know this from our very first day. What happens to sine and cos when we change to the other spot in the triangle? Root 3 over 2. 1 over 2 and root 3, because it's root 3 over 1. Everybody cool? Now, stop for a second and think about this. Is there anything new here? It's right angle trig. SOHCAHTOA, yes? Now you have a new thing that you have not, it's not new, but it's something you probably haven't thought about, obviously, yes? Now, because we're in the 10th grade, what are we going to do with this? We're going to apply this to another situation, because this is the basics, yes? 1, root 2, 1, 2, root 3. Everybody cool? All right, let's turn your page over to 85. Or 80 for you guys. Please highlight the word exact values. Up until now, have we been dealing with exacts? No, what are we dealing with? Decimals and rounding, yes? So exact means what? No more decimals. So what does that mean? Well, just like we just drew, 1 root 2. Until today, would we leave that as root 2? No, we would write it as 1.414 and we would round it off, wouldn't we? Now, we are leaving it as a root. Everybody cool? This is what you need to do. You can read it for a second while I set this up. Okay? So read that over. Just read it. Make sure you know what all of those terms are. And by all of those terms, I mean everything highlighted. Know what the terminal arm is. Know what the reference arm is. Know what a special triangle is. And then you'll be in good shape. Is everybody comfortable with those 3 things? All right, let's do the very first one. So, remember, we want exact values, no calculator. Where's 45? Halfway through which quadrant, Karina? First one. There's 45. There's 45, correct? So, have we drawn the terminal arm? Yes, it's right there. Have we found the reference angle? Yes, it's 45 right there. Now I decide on the special triangle. What triangle is that? 45, 45, 90, right? So what do I know about this? According to the work we just did, how long is this? 1. And what else do we know? Because of the circle trig, it's positive 1, don't we? What's this? 1. Soon as I know 1 and 1, what's this automatically? Root 2. So now I want the exact sine of 45. Sine is opposite over hypotenuse, right? So it's 1 over root 2. Easy peasy, right? Everybody cool? Let's look at the next one. Draw a grid. Where's 60? First quadrant, up like this, right? Because it's got to be the steeper angle. Everybody cool? Yeah. So what is this? Once I recognize that 60, this is the short side. So how long is it?
30.
No. The short side. How long is this? 1. How long's the hypotenuse? 2. How long's this side? Root 3. Now can I find the exact cos of 60? Easy peasy, right? You know it from the page we just did. Cos of 60 is 2 over 1? 1 over 2. Everybody can do it in the first quadrant, yeah? All right. Now, this is grade 10. Apply what you know. Because this, C, ain't no first quadrant, is it? So apply what you know. What do you know how to do here? You know how to draw the grid. You know how to put in the terminal arm. Where is it? Which quadrant? Quadrant 4. There it is. Does it matter how I draw it? No. What's the reference angle? 30. Do I now know what special triangle I'm using? Yes. If 30's there, what's here? 60, right? Okay. How long is the short side?
1.
Look closer. How long is the short side? Think about everything we've done in trig. How long is the short side? -1. How long is the long side? The long side. Side, not the hypotenuse, the long leg. How long's the long leg?
Root 3.
Root 3. Positive.
Yeah.
How long's the hypotenuse? 2. Why is it not negative, Jenna? Because it's the radius. It can't be negative. So now, what is the tan of 330?
I know this tan of...
So it's -1 over root 3. Yay! Does everybody see what you did there?
Yeah.
You took something that was easy that you explained, no problem, in the first two, when it's in the quadrant you're happy with, and you applied it over here. What happens with D? Where's the terminal arm? Third quadrant? Third quadrant. Third quadrant. I'm just messing with your heads. If you know the answer, be strong. Right here, yes? What's the reference angle? .45.
Yeah.
Once you have 45, what do you know? -1, root 2. Can you find the cos of that? What is it? -1 over root 2. Everybody see how to do it? You guys try EFGH. And that's going to take us to the end of the day. I want you to finish 85 tonight. Or 80. Sorry, I forget that you guys are 5 pages behind me. Finish 80 tonight. And I will include the rest of 80 in the key I will post. Tomorrow, you work on 77 to 79, was it? 77, 78? Whatever B1 and B2 assignment is. Good? Everybody cool? Now, remember, 45, 45, 90 is pretty easy to work with, right? But the 30, 60, 90 gets funky. So I highly recommend having a very good look at this. 1 is opposite 30. Always. Tavleen. I have an answer about E. Well, let's draw it. Where is 240? Out here, yes? Oops. There's the terminal angle, yeah? So 240 is 60. That's our reference, yeah? Which makes this have to be 30, yeah? Which makes this have to be opposite 30, has to be 1. I'm going left, so it has to be negative 1, right? And this has to be negative root 3, yes? Because I went down. And that's 2. Then I just do my work. Now, the other thing that helps you here is cast, yes? As soon as you see that your terminal arm is here and you're dealing with sine, you know it has to be negative. That's what I mean about bringing everything to the party. Every single thing you know about trig I lie. Every single thing you know about math can come to this question because the coordinate grid isn't trig, is it? The coordinate grid is something we are applying to trig. Everybody understand? Which one?
The one I just did. I kind of drew different, but...
Well...
I did.
Yeah... Because you didn't find the reference angle. You put your 30 down here. So what you did, Max, was you did this.
Yeah, I did that one.
I don't care. It'll still work. Because this is still that degree. I wouldn't do it that way, but I can't tell you how to learn. I can only give you the tools with which you need to carry on. All right, I'm going to shut up, and I'm going to write right on here, remember, finish page 80, and tomorrow is page 77 to 78, you said? That's Thursday. The key will be up sometime between now and tomorrow evening. The key will go up on YouTube. The key for these last 4 questions and page 78, 77 and 78. And I lie, it's not a test. Your next quiz on circle trig will be Friday. Everybody cool? This is going to be on YouTube. Everyone relax. Here, circle trig. Ooh, target trig. Everyone's favorite kind of trig.